students, industry professionals and any other who are interested in NPTEL courses. My name is Krishanu Biswas. I am working as a professor in the Department of Materials Engineering of IIT Kanpur. I would like to talk about this new course which will be floated from July 2025. This is a 12-week course on introductory material informatics, and this will be offered first time for all the students who are interested to do how data science can affect the materials design and discovery of new materials for predetermined properties. So, there are two instructors in this course. First instructor is myself and second instructor is Professor Pratik Ray. He is from IIT Ropar. So, both of us are going to teach this course and deliver different lectures.
Hey everyone, my name is Pratik Rai and I am a faculty at the Department of Metallurgical and Materials Engineering at IIT Ropar. And I'm really excited to teach this course on Introductory Materials Informatics jointly with Professor Krishanu Biswas of IIT Kanpur.
So, first of all, let me tell you why material informatics is so important. You know, material informatics is or has been transforming the way materials are discovered, designed, even developed or deployed. There is no doubt that this is going to be new way of designing and discovering materials for various kinds of applications. So, use of informations or data science, what we call about it, helps make better decisions that we know from our earlier courses like artificial intelligence. This is very well known in the literature and also in the minds of many of you. So, it provides insights into the risks, patterns and trends of different kinds of design and discovery processes. So, in this course, we specifically learn about the impact of data science on the materials engineering with emphasis on informatics, data-driven approaches as well as different kinds of computer or AI based models which will be widely used. So, data might be derived from various experiments, theoretical calculations that we will surely talk about it, or it can be curated by oneself.
I think there is absolute need to reiterate the importance of machine learning in modern engineering and in solving the modern engineering problems. I'm sure you're all aware of that. What I would, however, highlight is that over the last century, for the last several decades, lots of experimental work has been done in the field of materials engineering in looking at how you synthesize new materials, in studying the properties of the materials and so on and so forth. So with this vast repository of data that is now readily available to us as 21st century materials engineers, we are ideally positioned to combine this vast repository of data with the techniques of data science in order to do materials informatics based studies and therefore go about designing new and novel materials with rather unique properties.
So, first of all, these are the different things of the course. We will first initially talk about some introductory concepts, provide you some glimpse of the material informatics. Just now I talked about it, we will elaborate more on that. Then we will get started with ML models and applications, followed by data repositories and featureizations. Lot of discussions will be on data repositories, featureizations, how data are created, how data are curated, how data are sold and how we can use that. So, finally, we will talk about how structure of materials and microstructures can be used as a tool for informatics, and obviously, we should also deal with how informatics can be done thoughtfully, not like any way you want. So, first of all, what is informatics? What is informatics? You think about it. So, this 2 minutes talk what I given, this must be giving you thoughts. What is informatics? It uses information science with computational science basically, what is known as computational engineering, to improve the efficiency of material development. As you can see on the slides, it has to combine the concepts of materials and engineering with this informatics and data science. Why? Because it can help us understand, select, deploy, development as well as discovery of new materials at a very fast rate, the rate at which we can think of our life is moving. So, this is really an effort to improve the efficiency of material development cycle. As you know, material development cycle is very long, normally 25 years from the day you discover a material till you can use it in actual applications. We want to reduce it to 10 years, and various countries in the world have started spending a lot of money on that. So, we have to cater to the need of this next generation people who are actually will be doing this job. So, we need to train this manpower who can do this job. So, in US they have started a concept called materials genome initiatives. In Japan and China they have started a concept called Industry 4.0, and these concepts are specifically based on AI driven approaches and in which data science plays the most important role. So, we would like to train the next generation of students, researchers on these aspects. That is our basic motto of this course, and in order to do that we wanted to float introductory course at the beginning, and we will basically follow a simple methodology to teach you so that you can understand all these aspects. So, now the question is, we are talking about data science. What do you think is data is? Are there enough data in material science? Well, data sets or data are going to be the key factor in any kinds of engineering and science in future. And in material science, we know there are several types of databases already exist, like databases of material behavior, properties of material, mechanical, physical properties. Many of you know there is a book called Smith's Handbook or ASM handbooks, where all material property data are kind of compiled after a lot of checks and balances. So, these exist to us for a long time, but we have never used it to discovery of new materials for this data. Then also we have data in terms of thermodynamic databases, that is well known to many of you, and how to use thermodynamic databases to design a new material, that is not been taught. A new subject which is coming in picture is computational thermodynamics. So, we would like to integrate that computational thermodynamics with the thermodynamic analysis of these in this course. Other than that, you can have crystallographic databases and curated databases which you can create yourself, correct. So, crystallographic databases are also known as a Pearson crystallographic databases, which contains information about crystals across all the crystal material in the world. So, in a nutshell, these three databases, material property databases, thermodynamic databases, crystallographic databases are existing for ages, almost 50 years I know as far as myself is concerned, but we have not been made any efforts to make use of these databases to design material in a informatics way. That is the basic reason we have chosen these topics to teach you. Now, as far as curated databases, you can create your own database you want. Basically, you can create means you can take a lot of experimental data or maybe calculated data like from simulations and create your own database. That is one of the key things about material informatics. So, now let me also tell you, but that is about the databases which you can use it, but are these databases enough for us to do the data science? Obviously not, because we will require more data to do that. So, one of the problem is in material science is this data are available, but many cases you have sparse data. So, that we will handle.
Having said that, I think it's important that we talk a little bit about the nature of materials informatics problems. If you look at different engineering materials, they are quite multifaceted and complex. And if you look at the experiments that people have been doing in the literature in order to study these materials, you will find that these experiments have been carried out under a diverse array of conditions. And therefore, once you start narrowing down your problem, you will see that there's only certain data entries that will come into your database. So once you construct your database for your own specific problem, typically you will see that you are handling hundreds or maybe thousands of entries of data. Now, this is not a small volume of data. This is actually a very good volume of data. However, it's not so large to term this as a big data problem. So one of the things I want to reiterate to you is that when we are doing materials informatics, we are actually looking at sparse data problems. Of course, there will be exceptions. There will be certain problems for which huge amount of data is already available and well curated. Those are the exceptions. But as a rule, when we are looking at problems in material science, you will find yourselves handling relatively small amounts of data. So what does this mean for you as the materials engineer who is using the techniques of materials informatics in materials design? It means that you need to have your core competency, you need to have bring forward your domain knowledge and combine that with the techniques of machine learning in order to do materials informatics meaningfully. The smaller the size of your data set, the more important the domain knowledge becomes. And therefore, as we go through this course, you will find that we will have small refresher modules which introduces fundamental concepts of materials, which introduces important properties of materials and important facets of materials, which is going to be important for you if you are able to use those techniques of machine learning properly.
Secondly, we will also talk about a lot of interesting topics on AI ML models and some mathematical stuff which you all will be doing that. Mathematical stuff in the sense of how to handle data like matplots, data cleaning, and some amount of Python script also will do that, and that is part of this.
So when we go about predicting and designing materials, what are we really trying to predict? We try to understand how a material is going to behave under different conditions. We try and figure out ways in which we can optimize the properties, tune it, and improve the properties, right? And in order to do that, it's important that we understand that when we talk about materials properties, there's really two different types of properties that we are talking about, namely the intrinsic properties of materials and the extrinsic properties of materials. When we talk about intrinsic properties, these are properties which are primarily governed by the composition of the materials or the material chemistry. And when we talk about the extrinsic properties, these are properties that can be tuned and adjusted by how we make the material or how we process the material. So essentially, as we change our processing approaches, we end up changing the internal structure or the microstructure of the material. And as the microstructure changes, so does the properties. So when we are trying to make some prediction about material, we are essentially trying to see that we are able to predict the behavior of the materials and the properties of the materials. Once we know how we can make these predictions, it is important that we understand and that we realize whether the predictions that we are making are meaningful or not. In other words, whether the predictions align well with the physics of the material. So as students of material science and engineering, we are interested in the underlying physics of materials. And therefore, one of the modules of the course is also going to deal with this aspect, where we show you how to develop physics-based machine learning models. So one of the examples of that is going to be PINN, or the physics-informed neural networks, where we start introducing or we start combining the laws of physics, the underlying material physics, with neural networks in order to develop physically meaningful machine learning models. A second part of this physics-informed machine learning is also to look into the underlying predictions and understand how those predictions were made, what was the decision-making process of the model. In other words, can we actually explain the different types of decisions that these machine learning models are making? And therefore, we will also look into different types of explainability frameworks to unravel the black box nature of this machine learning algorithms, specifically in the context of material.
Therefore, if you are serious students who wants to learn this course and in a very systematic manner, this is what you should search for.
One of the things we also hope to achieve in this course is to introduce some sort of a hands-on context. So when we go through the lectures, you will find that some of the lectures will be focused on exemplifying how materials informatics works. You will actually get a chance to see materials informatics in action, and we will show specific examples of how you can use machine learning in making meaningful predictions in material science. So if you have a little bit of a background in Python programming, feel free to use your coding background along with the code snippets that we show you during the lectures to start developing your own machine learning model.
So ideally speaking, we could have asked you to make a project out of it, but this is an online course, massive online course. These aspects are not so easy. So, but our TS will be engaging you in a systematic manner to teach you how to use these concepts and get a good hands-on training on these aspects. So, fundamentally speaking, our job will be to teach you the concepts both from the theoretical point of view as well as from the practical point of view, and our TS will be in touch with you for all kinds of hands-on training. And if you want to have more discussions, we can always have extra session on the when a TAs are going to talk to you.
And with that, I welcome you to the course. Sit back, relax, and enjoy your journey through the wonderful world of materials informatics.
At the end, I would request many of you to register for this course and join this course. You have seen me teaching artificial intelligence, machine learning, deep learning in a systematic manner, and this is the methodology I will be carrying forward in this course also, so that it becomes very useful for the young generation of this country, and we can create the future manpower. And with this, I will welcome you all to this course.